Hey guys, welcome to another session on maths for data sciences. So here we would be looking at the levels of measurements of variables as the topic. So this would be the first topic in the series of data analysis. We'll be studying what are the different kinds of variables here which could be studied in a data analysis task. So there are four levels of measurements. These are also called the scales of measurement, and they can be categorized as nominal, ordinal, interval, and ratio level variables. Now, the nominal and ordinal variables are also called categorical variables or qualitative variables since they don't have any numerical characteristics with them. So we'll see them. What do we mean by numerical characteristics? It means that they cannot be added, subtracted, or we cannot do arithmetic operators with them, and therefore they are categorical in nature. In that way, we'll look more into it in the coming slides here. While interval and ratio level variables are numerical and therefore they have all the quantitative properties or numerical properties that are supposed to be there for a numerical variable. Now let us try to look at them, each one of them in more detail. So nominal by the name means that something that exists in name only. These variables are nothing but just unordered categories or labels of some quantity. So again, there are no numerical characteristics to it because these are categorical variables and therefore we cannot perform any kind of arithmetic operations on these values. The only operation that could be done here is frequency count. So for example, if there is a variable like name of the student, it is possible that there are two students in the class with the same name and there are three other students with the same name and so on. So for each of those names, we can just do a frequency count, like the total number of students with a particular name, but we cannot really arrange these names in any, let's say, ascending order because we cannot say one name is greater than the other, nor can we add any two names, let's say two names Adam and George. We cannot really add or subtract them and therefore we cannot perform any arithmetic operations on them. Similarly, color of a ball, again, we cannot add or subtract any two colors, nor can we arrange them in any order, numerical order. And we can only present them in a frequency distribution way. For example, two balls which are blue and let's say five balls which are yellow and so on. Similarly, there are other variables like email ID of a student and unique roll number or identification number. Now, since the roll number, although roll number could be a numerical value, so for example, there could be a roll number 1, 2, 3, and then there is a roll number 1, 2, 2. Now, one can say that we can actually add these two to get 245, but this 245 could be another roll number, and this doesn't mean that that particular roll number in any intuitive way is basically the sum of two other roll numbers. These three roll numbers, although they look numerical, they still are categorical because we cannot say that a particular roll number in some way is greater than the other in any, like, it doesn't add any value in that way to that particular variable, and therefore although some of these are numerical, we cannot say one identification number is more than the other because they are just unique labels for the student here. And since we are looking at a unique roll number in this case, even the frequency distribution would not be possible here since each of these unique roll numbers would have a frequency of 1. Since these are unique, no two students can have the same roll number. So these are the kind of nominal variables that can exist. These are categorical once again, and they do not perform, we cannot perform any arithmetic operations on these kind of variables. Then we have ordinal variables. So again, these are also categorical variables. The only difference here being we can actually arrange the values of this variable in a particular order. So in nominal variables, we were not able to arrange them in a particular order. For example, name of a person, we cannot say that one name is greater than the other. But in this case, we can basically arrange the values in a particular order. For example, let us say we are looking at a variable levels of agreement, and it could be strongly disagree, neutral, agree, or strongly agree. Now we clearly know that we can actually arrange them in a way that strongly agrees, less than disagree, then neutral, then agree, and then strongly agree. So we are able to arrange them in a particular order, and this arrangement also means something clearly, that we are actually having a range or a scale of agreement in terms of a particular subject, and this agreement ranges from strongly disagree to strongly agree, and therefore there is a particular order in these kind of values. Now, even though there is an order, we cannot still add or subtract or perform any arithmetic operations on them, and therefore this variable still is a categorical variable. The only difference from nominal variable is that they can be arranged in an order, and therefore they are also called the ordinal variable. So the ordinal word itself shows that they can be arranged in a particular order in that sense. Now next, another example could be stage of a disease. So for example, the stages could be 1, 2, 3 and 4. Now again, the fourth stage would be more severe than the first one, but again we cannot really add any two stages here. And another thing to note here is we cannot say that this difference between stage 1 and 2 is same as the difference between stage 2 and 3. It is possible that from 2 to 3 the condition become more severe than it was from 1 to 2. So we cannot still say that the difference between two consecutive stages is the same here. We can only arrange them in a particular order, but we don't know like what is the difference between two stages here, and therefore we cannot say that the distance between let's say two consecutive 3 and 4 or 2 and 3 are the same differences or same distances between any two categories. So the only thing here to note is that we can arrange them in a particular order. Now moving on, we have interval level variables here. So this is a numerical or a quantitative variable. So nominal and ordinal variables are categorical, and now the interval variable is a quantitative variable, and there is an order to these values as well, but the distance is also well defined between any two values here, which was not the case in case of ordinal variables. So order once again is defined just like ordinal variables. The distance between any two variables is measurable and well defined, which means we can also do arithmetic operations between any two values of these kind of variables. So for example, there is no true or natural zero value here, and this we'll actually see in case of why it is different from the fourth kind of variable, which is a ratio kind of a variable. So we don't really have a true zero in that sense, but we can still measure the distance between any two values. So for example, like temperature is one of the most famous example for an interval level variable. So let us say we can have a minus 32 here, and this, let's say, and minus 16. So we know that we are adding 16 here to get to minus 16, and similarly we can have a value 16. We again add here 16 and we get 32. So the difference between 32 and 16 is same as the difference between minus 16 and minus 32, and therefore we can actually measure the difference or measure the distance between any two values here. But as the temperature can have, although temperature can have the value 0, it is still a particular value, like it doesn't represent a left hand limit. For the temperature scale, the values can go on both directions of 0, and therefore there is not a true 0 value for the variable temperature here, because it is just like any other value which lies in on the scale. It is not the ending value in any way, since we can go in negative values as well for the temperature variable, and therefore these are called interval variables. Why they are interval? Because we are able to capture the distance between any two values, which represents the interval between the two values. So that is how you can remember the definition of this kind of a variable, which is an interval level variable. So once again, just doing it in a more readable form, for a temperature measured in either units like Celsius, we can say that there's a difference between 30 degrees between 60 and 90, while there's a difference of 40 degrees between 60 and 100. Therefore, the only difference between ordinal and interval levels is for interval level variables, we can do the arithmetic operations. As we can see, we can subtract two values here, which was not possible in case of ordinal, but there is no true zero in case of interval level variables, which will be there in our fourth level of measurement, which is called the ratio level, which we will see later. Now, as there is no true zero, so there is no true zero defined in case of a temperature scale, we cannot really say that 100 is twice as hot as 50, because again, these are just continuous values. We only can say that there is a difference of 50 degrees between 50 and 100, but we cannot say that 100 is double of 50 in a hotness way or in terms of the warmness on the temperature. We cannot say that 100 degrees Celsius is double in terms of hotness, because that could be a subjective way to look at things. We can only measure the difference between these two values. Now this is where the ratio level variables comes in. So these are again numerical variables, and they have all the features which were there in interval level variables, but the extra feature here is they have a true zero value here as well. And since there is a true zero value here, we can also measure the ratio between any two values of this kind of a variable, which was not possible in interval level variables like we saw in a temperature variable. So most of the numerical variables we see normally are ratio level variables. For example, let's say height, salaries, and weight, time to reach the office, and so on. So for example, let us say a person A with a salary of 30,000 has double the salary compared to a person having a salary of 15,000. So we can easily say that the salary here is double, which we were not able to say in case of a interval level variable. So this is it from this particular session. Let's jump to the next session.